Go ahead and get started. Welcome everybody to our Slice of PI-CASC seminar hosted by the Pacific Islands Climate Adaptation Science Center. Yeah, everybody. Hope everybody's having a good start to the year. Thanks to our team for working through those technical issues. All right. Looks like everybody here helped themselves to some lunch. Great, excellent. Welcome. Thank you for the full room, everybody, for being here. All right, so this Slice of PI-CASC seminar series is intended to provide a venue for sharing state-of-the-art climate adaptation research and science to management applications in Hawaii, the U.S. affiliated Pacific Islands, and beyond. This presentation is being recorded. It will be available on our PI-CASC website on our events page if you want to share it with anybody afterwards or go back and look at it again. Those of you online, aloha, welcome. Thank you for joining us. Please keep your microphones on mute. We will come back at the end of the presentation and have time for questions and discussion with our speaker. Those online, feel free to leave any questions online in the chat along the way, or we can have you buzz in at the end of the talk. So today, we are very excited to have Dr. Aurora Kagawa-Viviani joining us to share with us on community ecology to community hydrology, island ecohydrology from forest to city. Dr. Kagawa-Viviani is an assistant professor with the University of Hawaii at Manoa Water Resources Research Center and an assistant professor in the Department of Geography and Environment. I'm going to go ahead and let you get started, Aurora. I don't like your introduction, but we ate into some of your time. I want to make sure we leave plenty of time for you. But everybody join me in welcoming Dr. Aurora.
Thanks.
All right.
Sorry, I should have started trying to get this squared away. All right, here we go. Zoom, share. Oops. Let me get out. You think I know how to do this after teaching, but I realize I'm not going to get presenter view.
No, you're not.
So, we'll wing it. Okay, am I okay? Okay, and then I'm going to hide controls, right? Where's my hide control? I'll just hide it in the middle. Okay. All right. Thanks everyone, and for the entertaining my mouthful of a title and abstract. So I really appreciate the opportunity to talk in this seminar. As a graduate student, I always wanted to be in PI-CASC or PI-CSC, and I was never part of it. So I think Rachel added me to like the seminar listserv, and so I'll admit, this is the first long talk I'm giving at UH since my job talk. And it was the stimulus to try and figure out like, what have I done since starting at UH? And then how do I explain it? Because it's sort of wildly varying. So today, this is my talk, and I'm gonna say 3 acts, but the middle act will be tightened from my postdoc work, taking you from forest ecohydrology work I've done in my dissertation, and would like to raise the profile of ecohydrology in Hawaii, and thinking about how I am now taking those tools from working in forested environments into the urban system, which I now, for practical reasons, am working in. And so, yeah, thanks for joining me. And okay, so I'm first going to talk about ecosystems and hydrologic processes. This is a figure. Let's see my mouse here. You guys see my mouse? All right, up in the right corner is a figure from GAN, the Society of Ecological Restoration Continuum. But if we think about a landscape, in conservation, in which I was trained, we tend to focus on relatively pristine forested ecosystems. And you do ecohydrology, you really like to minimize the human footprint. And yet our landscapes are increasingly urban, and we need to be contending with that, as the LA fires sort of remind us. But for the moment, let's think just about the forested system. And the questions that are relevant to ask are, how does the forested system change flows of water? Is all forest just forest, or do species matter? What are the implications then for biotic invasion, where you have an ecosystem transformer such as strawberry guava, taking a diverse forest structurally diverse and species diverse system into a monotype. The second sort of brief act is going to focus on my postdoctoral research in with the USGS Pacific Island Ecosystems Research Center in HCSU, focused on really a different setting where instead of data taken by sensors from forested systems where there are no people, I was interviewing, I and my team were interviewing restoration practitioners across the islands and conducting surveys to understand this embodied knowledge that they have from years of practice that never gets written down because they're too busy saving our ecosystems, flying helicopters, making fence, controlling weeds, and applying for grants to keep it all running. And then the third act is how I'm taking ecohydrology into urban and urbanizing landscapes. And so this work is really new work by students I'm working with on Oahu, and particularly in the Ewa region, and stimulated by the awareness of fresh water in the urban systems that was catalyzed by Red Hill. And also where that's taking me out of my comfort zone with sensors into the world of contamination, where Eileen and I think I'm very appreciative for the work she has been doing. So just starting with ecohydrology, how many of you are even familiar with the term ecohydrology? Okay. Oh, well, actually that's more people. How many of you associate it with like Yin Fan Tsang's brand of ecohydrology and aquatic ecosystems? Hands up. Okay. How many of you think of forests or plants? We should talk some more. This is very exciting because I sometimes feel quite lonely in the College of Social Sciences where I don't get to talk science that much. But what I used to explain was from an ecohydrologist point of view and from a plant's point of view, evapotranspiration is the good thing. From a water resources point of view, ET is a loss and a waste of water to an aquifer or freshwater system. So it really depends on your point of view, what value you have for this flux of water. And I used to study evapotranspiration, but the example I'll provide you is how plants potentially modify infiltration through vegetation structure and effects on soil, kind of soil physical properties. Hawaii I think, is special in terms of ecohydrology, and it's also different. It's really challenging to talk to continental ecohydrologists who are used to having like $1 million budgets, working in CZOs, having flux towers, and large footprints with flat, large footprints which are necessary for the needed fetch to get a good measurement of carbon and water fluxes. What we have is unique, and we have to overcome those challenges when doing ecohydrology research. So this map is on a visualization of aridity. So that's potential evapotranspiration over rainfall. Thank you, Rainfall Atlas, ET Atlas, Ryan Longman, who is instrumental in that, as well as others in Tom Jambaluka's lab. But we have a tropical, subtropical climate, strong environmental gradients, complex topography, which you don't capture when you see the world in 250-meter grid squares. We have issues of urbanization that I don't think we're facing real well, at least in the sort of ecosystems focused circles I'm in. We have biodiversity and invasion issues, and that's where I bring in community ecology. And we have widespread conservation and restoration and a focus on hydrologic ecosystem services because of our dependence on a limited, essentially infinite, but relatively limited water supply for municipal and agriculture and all purposes. So framing ecohydrology for Hawaii requires thinking at the scales that are our reality. And there's been good studies that have been done over the years. Sorry, that font is too small, but a lot of them focus on forested systems or plant ecophysiology. This is not updated since 2016, but there is a bias towards studying not on Oahu. And yet we're facing effects of climate change that are different for different parts of our landscapes. And this creates a sense of urgency to understand not only how is climate change going to affect our forests, but for those in water resources, how is that effect on forests going to then affect our water supplies, flood kind of flood, sedimentation. Big one that USGS focuses on is groundwater recharge. And there are a lot of assumptions. I'm a field person. I like measuring things. People who do models, they have very nice maps, but I always wonder about those assumptions that go into those model parameters. So to me, there's a lot more work to be done, kind of bridging the field measurements. A field of hydrology that's not represented in Hawaii is hill slope hydrology, and really scaling up. And that's like a classic challenge in ecohydrology as a discipline, is the issues of scale. But I think we have opportunities and critical mass in Hawaii to really tackle ecohydrology more strategically. Going back to the ecosystems, we have so many ecosystems across our landscapes, right? We have desert, this Paul Kay's image. Sorry, my mouse doesn't work. Way up at the top with that silver sword, where, really it's about there's not a lot of water, infiltration's high, rainfall's low. We have a charismatic macroflora to help us think about plants and water in arid landscapes. We have arid landscapes at the coast that are also saline. We have cloud forests that are really important for recharge. We have islands where there's rock, and no matter how much forest you have or denudation, the water is going to go vertically downwards. And then we have old islands with very different kinds of substrates on Kauai, where you remove forest, you compact soil, you burn the soil, it becomes hydrophobic, and you're changing flows. So there's a lot of, to me, interesting questions about what happens on the skin of the Earth's surface with the vegetation and soil. And again, I have this kind of behind it all is the Board of Water Supply's classic, probably wrong model of the island's aquifer with dikes. There's like little horizontal, that's the perched, and then there's the basal, to remind us all about how relevant this, like our epidermis, the skin of the Earth, is for our island water resources. And we haven't even mentioned contamination, but we won't here until discussion. So the questions I used to ask were like, when, where, why, how might plant species matter to hydrologic processes? And I focused on strawberry guava, Psidium cataleanum, because of its ability to really transform ecosystems. This is just a great little video of how efficiently the trees of this particular form capture rainfall and funnel it down trunks. And Mohammed Safiq had shown in his thesis just how efficient strawberry guava is at funneling stem flow. It also changes properties of soil. So, there's lots of papers on the antimicrobial properties of Psidium, of the guava family, and what this does is it eventually produces a buildup of organic matter at the soil surface, which seems like a good idea, right, if you're trying to build soil. But what does it mean ecologically for other plants that may not be able to access it? I'm not going to go into the weedy details of plant water potential, but this has implications for the understory and for also the redistribution of water of that stem flow during rain events. So this is a bit of an anecdote rather than robust replicated data, but during my dissertation, I stuck some extra sensors in the field because I was noticing this like effect of like this rainfall funneling, and I was curious where it was going. And so I'm not sure if you can see that well, but it's so tiny. Okay, I'm just gonna talk it out. This is a static diagram, but I like animations. On the blue, just look at the graph on the left with a small rain event. And the blue is a native forest stand. On the left with red is a guava stem. What you see with that solid red line that's sort of swinging back and forth is soil moisture between the trees. And it's what you see in the small event is that when it rains, soil water increases along the profile for a native forest, whether you're at a tree base or away. And in a guava stand, you see a very different pattern if you're at a tree base or further away. It's much more dynamic. And what this kind of implies to me is that during rain events, in a shallow rain events, you can have infiltration is limited in the guava stem to the soil surface, and there's a dense root net that trees form under there, and so there's potentially different profiles. So this needs to be followed up with a replicated study, maybe using tracers, maybe using ERT to understand how trees themselves can redistribute water and what implications this might have for recharge, for the ecosystem and invasion itself, and potentially for the aquifer, though that would have to be scaled up. So the take home is that small rain events under Cidium are converted into shallow soil moisture, maybe harvested by the tree and redistributed because, sorry, I'm going into the weeds of preferential flow, but it's moving water differently in a native forest than a guava forest, and through different mechanisms, through the tree structure, through the way it alters soil properties. What I didn't show so much is it appears that under large rain events, these trees actually route water. If you look on the right, that little dashed line, that red dashed line shows sort of no increase in surface soil moisture, but a routing to depth. So my point being that this is just one example of a mini, like tiny piece of a picture ecohydrology question. And you can use ecohydrology to think about water for the ecosystem or water for the forest. And you can also think about how forest types, species compositions, again, alter water. So, which way do you want to look through the lens? So this has implications for thinking about how climate change may affect forests, how forest alteration or restoration may alter hydrologic properties in ways that we would like or ways that we are concerned about. And so in my postdoc work, again, I mentioned our team interviewed many restoration practitioners and found that restoration is driven by different motivations, conducted across a range of environments, and characterized by a diversity of activities. Yet there are certain kind of themes that are common. And so we asked, again, 2 questions about ecological restoration and really focused on the practitioners, what works in different places and why, because there is this siloing of people doing work in the field, and maybe through synthesizing what information we can, finding key patterns and helping make connections, we can improve their ability to do restoration and conservation work. And also at the same time, understand how the implications of that work for water. And as an example, I will just tell you that as we were doing interviews, I learned the East Maui Watershed Partnership was the first of the watershed partnerships, specifically because plantation interests understood the value of that water that they needed, EMI needed for irrigating. And so on Maui, watershed protection is very water resource motivated. If you're working with Pohakuloa or DOD, the motivations for doing restoration or conservation are very different. And correct me if I'm wrong, Ko, is it Section 7 of ESA? Like there is federal mandates that then require compliance. And so the way people do restoration is oriented around their mandates and how they do it. But there's still a lot of lessons that can be kind of learned and are learned. People gather every year at the conservation conference, and there's informal networks where that information is exchanged. So we did an online survey of restoration practitioners, did some semi-structured interviews. I am looking forward to 2025 to work up this very overdue data set. And we synthesized technical reports. And when I say we, I meant my team. Where are they? Melissa Kuntz, who I saw on the call, Corey Yanger, and Liat Portner. So the goal now, and Liat is now working with Clay Charnick on ecosystems extension out of CTAR, is that we can take this information and sort of package it in a way that we can give it back to restoration practitioners so that it can be helpful. And what we found, especially in reviewing technical reports, is there's this body of gray literature that is not indexed, that is really good science coming out of, say, Volcanoes National Park on fire, post-fire recovery. But nobody finds it unless you know about it. And many of the people who know about it are near retirement. So how can we sort of reinterpret it for the present and provide it so that it's useful? I'll skip through this part, but we had survey participants that were biased to Hawaiʻi Island because of our networks. And they included a lot of folks who started as volunteers or students, became field technicians, advanced to field supervisor, continued on in research. And so many survey respondents had, over 5 years of experience. Many of their restoration activities focused on taking relatively, I'm going to say degraded because it's a value-laden term, but relatively disturbed systems and making them more native. So this bottom graph shows a line, and anything below is meaning it's pushing towards more native dominated cover. And this is in line with sort of ecological restoration norms, where the objective is to restore native species or diversity. And consistent with those objectives, a lot of people spend time in weed management. And so there's this critique in conservation or restoration that it's just gardening. But when you talk to people, it's not just gardening. There's a lot of science, there's a lot of ecology. So, okay, weed control is on the top left here, outplanting, fencing. A lot of effort, energy, and time is spent in these control settings. And then outplanting is dominated by outplanting both native common species, direct seeding, and then outplanting threatened and endangered species. And there's whole discussions about post-fire restoration and the availability of propagules around that. So when we asked about the biggest challenges to restoration, not surprisingly, threat management is a big one, managing weeds, and also directing ecosystem change and sourcing plants, but weed management by far. Climate and environmental change are also concerns, as well as funding and organizational capacity. That came through a lot, especially with program managers just trying to keep the lights on, the wheels fixed. And so one quote goes, depends on the space, but generally the introduction of invasive species and interplay with climate shifts and our capacity as an organization to address those impacts. And I'm really glad, like Elliot Parsons, with risk is supporting more work in this space. So thinking about this in a more holistic framework, however, a lot of the science that I have been trained to do focuses on the ecosystem, focuses on weed management, species interactions, but it's couched in this bigger landscape of climate and environmental change and funding and organizational capacity. So if all we focus in is what kind of herbicide to treat which invasive species, maybe that's not necessarily having the impact that's needed. And how do we help managers think about the broader context in which they're doing their work so it can be more impactful? And so I'm glad Ryan, along with PDKE, has created these portfolios so people can know at my site, rainfall is going to decline by X% in these parts of our domain, or it's going to, I don't know all the others. Are you doing like sea level rise? There's different climate threats for different ecosystems. And so it's really hard for managers, I think, to parse these very large scale statewide maps of climate change impacts when they want to know what's happening there, and then also get some guidance on what to do about it. And then broader questions about capacity I've been having with Clay Char and Acton. We can't, prescribing weed treatment when we don't have an ability to keep personnel on board is an issue. So I'm just watching my time. This is getting back to hydrology, but through these conversations with many people who work in different ecosystems, Leon and I began to think about, again, those restoration challenges on the left blue column, and climate change concerns. Again, you know, an alpine desert is going to see higher temperatures. That has implications for the physiology, perhaps, of the silver sort. Paul Krishnicki's done this. But like in the mid zones, invasive plants were a big concern, like a lot, right? Everybody working native plants in this sort of middle area. It's too dry to have big invasive species issues in Haleakala, at least in the really dry spots. So how managers are going to confront these challenges, at least on the biophysical side of the picture, needs to be, could be supported better by researchers being deliberate about thinking about the threats that managers, everybody says we want to do research that's useful, but I think trying to figure out what those questions are is a little bit, I don't know, I don't think there's a good recipe. Maybe Sea Grant, you have lots of extension folks and experience to do that, and ag and Sea Grant. But I think in ecosystems, that's why I'm excited that there's more work around ecosystems extension. So if you're, you know, again, looking at like, where are you in the landscape? Where are you managing in the landscape? What I'd like to do is go back to managers and be like, does this make sense? Are we capturing, you know, what you see as your threats? And how do we like develop this technical report or output in a way that's going to be meaningful and useful for you as you think about how to do restoration in the face of climate change and probably funding challenges. So I'm doing okay on time. So I interviewed for this current job I have, and then immediately after, Red Hill happened. And I like dealing with plants and water and got dragged into drinking water for a good year or two. But what that has done is shifted my attention to the urban landscape. And thank you, Allison, for this awesome picture. The reminder of just, you know, we spend all this money working up Malka, and for good reason. We need to protect our watersheds, but we really don't know our cities well. And we spend most of our time in there. And now that I have 2 small kids, I don't do field work for long stints off island. And how do we make the cities our system of interest? So you all have seen this map, this call log, but it just so happens my partner's at Leeward Community College and got a lot of reach out in late November to help with water testing. And I was a postdoc at Water Resource with USGS and Water Resources, asking around, hey, can we go test some water? And that was a wild, continues to be a wild ride. What it did do, so that, can you see that? Okay, so while my husband was like picking up samples in those little red blobs, for years, and my 2-year-old learned to say water sample a lot. I was also serving on the commission on the Red Hill Permitted Interaction Group, trying to research the Red Hill issue to provide recommendations for the commission's actions. So I was reading a lot of reports and going to a lot of meetings, and it made me aware of just how much infrastructure, like water infrastructure there is. These are different wells. I think a lot of them are monitoring wells on base, but in that box are a lot of supply wells of the Board of Water Supply, not just a lava shaft, but many others that source water to the urban core. I am not a groundwater person. And so I think I've tried to resist this for a very long time. But at these meetings, there are very few scientists, no scientists, except for staff in many of these agencies. And so I think it was important for me to accept, like, and try to learn as much about groundwater in this setting as possible, because we're getting questions, demands from the public to like, what are you guys doing about Red Hill? What can you do? You need a law degree. You need background in law to also interpret the code and what's doable. And it was a really complicated time, but what it did make me understand and think about was, you know, the fact that there's flow diverted by the secondary eruptions in this area. There's Eva Cap rock, and so water doesn't necessarily flow Mauka to Makai in the subsurface. It's hitting this like impermeable wall and getting potentially pulled this way. And in addition to those wells that we might hear a lot about, there's springs. So Sumida Farms and then Ka'onohilo'i is indicated kind of on the corner of that map. But not only are those springs there, there's a whole springs complex in Pu'uloa that I became aware of through public testimony, where people were concerned about the well-being of their springs. And I didn't know how to answer their questions because I'm not a hydrogeologist. And hydrogeologists maybe don't work at those granular scales or aren't necessarily interested in where those surface, at least except for Henrietta Dulai. So that has kind of made me much more aware of the ecosystems that are dependent on these urban springs. So there's Sumida and Ka'onohi's in the corner above Sumida. And it's just, how many of you have ever been to Kalawao Springs or Sumida? Yeah, have you been to Ka'onohi? Yeah, I mean, not a lot of people know about these. And the more you look, the more you find, maybe. But when you think about ecosystems in the urban landscape, we have turned our streams into storm drains, concreted them over. And so it's really uninspiring as an ecologist to work in these landscapes. But interestingly, that's like Halava Stream, because the fish can't, if you talk to Yinfan, the fish come back because at least there's water in the stream bed, because there was none before the Navy had to start pumping and treating water and discharging it. So there's these sort of complex ecological, odd urban ecological interactions, which are fascinating. But getting to know the area better, this is, we're walking the Pearl Harbor bike path with Andrew, you come across, this is Pu'uloa Natural Springs, and right below it is like, do not eat, right? Anything from Pu'uloa. Does it say what to not eat? It just says, don't touch it. And so environment becomes like a hazard in urban settings. We're afraid of contamination, but we don't even know what is there. And you can't necessarily, and at the same time, as we were walking there, of course, we saw people catching fish. The ones we talked to said they weren't eating it, but there are others who do, right? And if you're faced with having no food or food that's contaminated, you take a calculated risk. And so it made me aware of the EJ issues we have in our Honolulu landscape. And I think of EJ as like Baltimore and, you know, big metropolitan cities, but you know what, we're there. I accidentally didn't take that mask off, but this is again along the Pearl City bike path. How many of you have ever gone on the Pearl City bike path? Right, not a lot of people. It's fascinating. And yeah, you have that fuel pipeline. So while people are worried about fuel in their water, you have cocoa farms and watercress farms and like fuel right here. And those fuel lines go all the way to the Tesoro refinery out at Kalailoa and is beneath your feet. So like with groundwater, with this underground infrastructure, we don't know it's there. We don't care about it until it breaks. And then suddenly we're like, oh my God, what? And people calling me up asking me if I'm drinking water in Manoa. And I'm like, but I know where my wells are. You don't know? And then I realized most people rent and maybe don't get their water quality reports. And I'm like, oh, we have a problem with water literacy. And it's also fascinating to see how ecosystems in the urban and urbanizing landscape work, because on this particular day, I went with Andrew and Henrietta to Hiko, where there's a natural spring. You know, I don't know how many MGD coming out of there. And this is the Honouliuli National Wildlife Refuge. Do you know where its water source is? Wild guesses? See that pipe? It's like pumped. So these threatened and endangered species rely on a well, pumping water, while there's natural springs supporting infrastructure. And so this is interesting, like sort of human environment interplay. So I don't have research questions yet. This is just like a new system for me. But the lab group, we're working, I'm calling it, it's a reach. I like that joke. Restoration ecohydrology and community hydrology. And, you know, it's to tend to my desire to work in forested and nice systems, but also the reality that we do need to think more about our urban systems where we live, work, and play. Part of this was really kind of a mandate I heard it as a mandate when I was serving on the commission and talking to people. And they, one person asked, please ask the questions we want answered. Not you, we. And someone else saying, what's the purpose? Or who is this in service to? And it was a commission decision, but I could very well think about it like, what am I research for? Who is it for? Who is it benefiting? And another individual, trying to get my attention on groundwater, stating very poignantly, if the water could scream for help, it would be the voice of the people we'd hear. And so I'm like, now I've heard that, how do I unhear that? And what do I do? So this idea that I'm toying with students, with a collaborator from Colombia is like, what happens when I'm so used to, you respond to a call for proposals, you respond to a funding call, you come up with a question, or maybe you already had a question, and then you get the funding and you have to do this project, and then it ends in 2 years, right? And then what? And you leave, community's grumpy that you've left. But what if you try it more from the ground up? And it's slow, and I don't have papers to show for it. But what if we ask the questions from, that people want, that communities that don't get a place at the table? What if we ask those questions? And so it's taken me down this road of learning more about participatory action research, which comes from the social, or I guess planning, is it planning, and education maybe, and public health, thinking about water challenges more broadly, because of my work on the commission, and then INA work, which really excites people, gets people coming on volunteer days and makes people feel good, and is rejuvenating. And so this is my friend Angelica Gomez, and she asked a while back to me, how can citizen science go beyond participants as data gatherers? She does like a hydrologic observation on lakes citizen science program where they couple remote sensing data with community observations, just using like sticks. And she's like, but how can we treat them as more than just like free data gathering and crowdsourcing? And so she introduced me to the work of Hendricks et al. And there's Awesome Cell. There's this global sort of discussion in hydrology about hydrology that helps people. And this is not coming from the US, it's coming from Europe and IHS, which works internationally, knowing that a lot of researchers in, say, Africa or South America are like global north, come for summer, go back home. And so how do we build capacity in home communities to do the science? And we need to think about doing science maybe a little bit differently. So this ladder of participation, it's familiar to those who've done like CBPR or planning. It's this idea that, we might be at the bottom rung, but power is shared and collaboration increases as you move up. So, crowdsourcing, you give your data to Google on your phone, to community science where the communities ask the questions. She draws on the work of Orlando Falls Borda, who's Colombian. There's a lot of interesting stuff coming out of Colombia. And I had been unaware of his work until this past summer. So, his work is coming out of the 70s and 80s at this time of political change in South America. And I am in the Pacific and influenced by the work of Linda Tuhiwai-Smith and her decolonizing methodologies, which as a scientist, I'm trained in techniques and methods and statistics and sensors and whatever, mixing models and math, but methodology comes from social sciences, which is sort of the meta, like the why are you asking the question? Whose question are you asking? And so the methods are simply the means through which these sort of more I'll just say it like political problems of research are addressed. So maybe 5 years ago or 10 years ago, decolonizing methodologies was sort of fringe, and I think it's become more and more mainstream. It still makes people uncomfortable. So what I like to think about and makes me feel happy is this idea of restoration. And restoration projects really galvanizing a lot of different people with different views around a common cause. My framing around this work came from my pre-PhD times doing work in Kohala, where we had like a science research project in Puanui, Ahupua'a, in the middle of the Kohala field system. And the way I could get people, not the way I could get people, I was trying to do outreach. And then what motivated people was just to be able to access this aina again. I, as a researcher, had the privilege of having the gate combo and keys. People wanted to come and learn stories and history, and it aligned with their goals of feeding their family, supporting their visions of community, and restoring connection not only to land, but to each other. At the same time, what funded it was a coupled human natural systems grant, and that engaged archaeologists, soil biogeochemists. I was doing some informal ethnographic research, but there's research elements of the place history that come into play. And then my day job was climate stations, soil moisture, field cropping experiments. And so there's a role for like practice and experimentation and the kind of nerding I like to do, which is sensors based. And that together can build capacity and momentum and collaborations to help not only maybe secure funding. Now the site is run by a nonprofit, Ulumau Puanui, and it's taken a while to get there, but also confront challenges such as periodic drought, where you can have resource sharing because of the networks built through this collaboration oriented around a common interest in restoration. And restoration, I'm saying broadly defined. It could be ecological, it could, cultural. And so in the urban setting, the work around restoration is being focused initially around Punawai, or springs, from that Red Hill interest. And my grad student, I shouldn't call him grad, this grad student I am working with on this is Andrew Lewis. He's here. And he's done interviews with restoration practitioners, finding that in contrast to his previous experiences in the arid Southwest, restoring cultural values is a really important motivator for Punawai or spring restoration projects. The thing I really keyed into, and I was suspecting, was that stewards could use help monitoring their Punawai, their springs. Initially, I was interested in these spring sites as ways to monitor water quality in the aquifer and potential plume movement. But there's my questions and there's what stewards are interested in. They're interested in flow. They're also interested in water quality, but also temperature and flow rates as pumping patterns shift. And they notice, for instance, when the rail went in, some folks' flow dropped because you have a break. And that's, when you start talking to people, these sort of recurring patterns of how development or construction is affecting flows do come up. And I don't think those are documented. So Andrew may or may not keep going on there, that thread, but we are sort of building momentum around how to, where are urban Punawai, what do they tell us, and how can they sort of restore our awareness of ecosystems in urban spaces. Another student, technically Chi Chen student, Justin Kellum, has taken on an urban heat project I had wanted to do with eye buttons. We missed August and September in deployment prep, but are calling it an urban microclimate project where we've deployed about 100 small temperature sensors across urban Honolulu and Kapolei Ewa area, working with students from Leeward Community College to help deploy it. And Justin, we used ArcGIS Online to make an app for deployment and retrieval. And so we're building, he's probably collecting sensors now or this week, and we'll be looking at the data and excited. This will be like my first kind of data set. It'll be for urban Honolulu. And so some background is like, there was one urban heat survey, I think in 2019, and I can't even figure out what sensors they used, if it was optical, but it's a snapshot, right? And we know that on windy days, there's more mixing, there's localized effects. And so this is a bit more of I'm gonna call it a pilot or method development to see if we can deploy it. And my major question was like, how much does vegetation actually create a cooling effect in, oh, Justin there, thanks, Justin. How much does vegetation provide a cooling effect? Because where it where evapotranspiration causes cooling in an arid landscape, in a humid maritime island landscape, there's this assumption that there's no effect. You guys don't have urban heat issues because you're an island, but I mean, when you talk to people, there's definitely heat issues. So is it just shade, or what ways can we alter the landscape to ameliorate increasing temperatures, if at all? And then the last project I'll kind of share about is this effort we're just calling Why Community Matters, as a play on words. Bryson Tugade is my research assistant on this and helps on many projects. And we had initially been thinking about how to do place-based or aina-based research in EVA, originally around Punawai, but it's again shifted towards people's concerns towards around contamination, not in water and soil. So we're trying to find funding to do that work. Along with this dialogue has been this idea of creating educational away from our community college system into Manoa or into degree pathways that support students' journeys through from their home communities through the advanced degrees and hopefully back. And so I think we're piloting it with this existing Leeward Manoa relationship, but thinking about how it might apply to American Samoa Community College or other island colleges. Where I used to work at KCC, and literally we would hand our students to contact people at Manoa, maybe like Mike Guidry or Jane Schoonmaker, and then they would like help shepherd their transition and transfer and success. Barb Bruno is another one. So can we create educational away through research partnerships and projects that come from questions of that place, rather than being like, I need some students for my research project this summer, and becomes a one-time thing? Can we create robust relationships? So I don't have my quote here, but there's, I'm gonna show, oh, it doesn't, sorry, the sample rate. This is, I would call it a punawai, others might call it an uncapped well from in Pu'uloa. And as we were doing this punawai work, I became aware of a quote or a framing from Kepa Mali, and it's in East Maui. What is this? Waiokeola he wahimo olalo no Maui hikina, about punawai. And he was saying, you know, kupuna, to stand at the punawai, to stand there. And it's not just because puna is water, is because that way, the kupuna and the waiwai, is that wealth of knowledge that is passed down from generation to generation. When you stand at the, you know, when you ku at the puna, and the pu'una way is this like rising and bubbling, the hilling of the water. And I'm not giving this saying justice, but when on one of the work days, so as I build relationships and get to know Eva, I do work days, and I'm spending time, and there's a couple kama'aina, I'll name them Adam Hano and Adam Kekaula Hano and Kama Ka'aikawa, and they're like late 20s to 40. But when they talk about Eva, it's like I've gone back in time, because that landscape has changed so much in the last 20 years that they have seen it in their lifetime. And so this is, as we talk to people, this is a concern that Eva is very rapidly urbanizing. And what is the future of Eva for kama'aina of Eva? And how can we do work that serves their interests? So this idea of the educational awai comes from for me, comes from Goodyear Kaupua. Ma'o has sort of driven it a bit, Kamu Inos. And we're thinking about how to create these educational awai through research partnerships. Oh, I am sorry, I am overrunning. So with that, I just want to say this is current and developing work. And it's being facilitated by students I'm working with, thinking about like the regular science we do, and then science for, with, and by community on these issues of way and restoration. So thanks for your time. I got a little ahead of myself, and I think there's like room for one question.
Yeah, mahalo, Aurora.
Okay.
No, thank you very much for joining us. We set you back with those technical delays at the start, so sorry about that. Thanks for dealing with us on that. Yeah, let's take a couple questions. Starting here in the audience. Oh, yeah, I realized, yeah, we got your video on there. Apologies too, our video feed was frozen, but I do see that everybody was still seeing the slides and getting the audio online, right?
Oh, fine.
Yeah, there we
Okay.
go. Yeah, thanks, Aurora. Yeah, let's take one question from the audience and we'll see if there's one online, and then we'll probably have to wrap it up. Question here? Nobody wants to be the one question. Well, let's go online. Feel free to raise your virtual hand or just come off Zoom. I mean, off mute if you want to go ahead and ask a question online. They're being shy because they feel pressured now.
Is it that bad?
No.
Okay. Yeah.
I know the challenges from this side of things with trying to sort of reset and reframe how you're approaching the work, but I'm wondering what kind of feedback you're getting from people in the community about sort of slowing down the process and recalibrating how you're even going about doing research. Have you gotten any feedback on that yet, or even from students who are doing it?
I don't know, there's students on the call. I think I want to give credit to Carmela Vitsa, who I see on the call. You know, we did some community engagement specialist hiring, and I think it gave us at WRC, and it gave us a chance to really think about like what that means. I think it's a real trending word. And I remember, am I violating any HR rules? Carmela, I'm just going to quote you. There was a question about like, do you get the grant first? Or, you know, do you work with the community first and get the grant? Do you get the grant and work with the community? Because I know there's this tension, right? Like you don't want to waste people's time if you don't have funding, but also that people don't feel like they've been part of the process. And her response was like immediate. And she's like, you work with people first. And I was like, the clarity with which she said that was like very helpful, because I think it made me, like, we agonize over some things, like how to do it right, because we feel conflicted. There's a certain value, like I need to get a grant to get tenure. And so we're motivated and we think we can cut corners. And at the same time, you know, I've done work from community from the nonprofit side. And sometimes it's not that there's this assumption that like you need reciprocity and that's transactional, but actually what people want is somebody who shows up. And so actually from that workshop, and I didn't talk about the workshop we ran, you know, there's like, show up. The advice that Bryson and I got from Puonono Stibbard was like, the first time you go, now I'm forgetting it. It's like you watch or you work. The second time, like, first time you go, you maybe watch and observe. Second time you work. Third time, you maybe can ask questions, but you don't go with the question the first thing. Because, and I've heard this over and over again in urban hydrology work too, where it's like, you don't go with your title. And I think when you're from Hawaii or from a community, you know that because you're not trying to put yourself above. So like in academic space, I'll put the PhD, and in the other places, I don't have a title, because affiliation comes with privilege. And that power dynamic can really silence people because they don't feel like they can say it. And so often when I worked in community, oh, my partner's like, I don't have a college degree, you know, I'm not smart. And I'm like, no, you have like decades of knowledge of being a Paniolo and Kohala. And so we would joke that he was the PhD because he was the post hole digger and I was the master's because I just did the miscellaneous work. But like, I think having a sense of humor and being personable and being humble and not just to get access, because I see that too, like researchers just doing things to get access, and people know that, like people, communities know that. In Hawaii, researchers come in, come out, come in, come out. And so over and over in conservation, people come in, leave their flagging, don't clean up their flagging, don't clean up their equipment. You know, just being responsible and accountable, I think that's come through. So I haven't got direct feedback. I hope people feel like they can bluntly say it, but I know people, you know, Hawaii, people don't like make waves. So, but if you can, you know, you can, I think if you try to key in, you can hear it. So I don't know. That was a long answer. Yeah.
Thank you for that. We do have to wrap it up, and I think
Okay.
that's a great note to end it on anyways. Another round of applause for Dr. Thank you. I want to invite you all to please join us for our next Slice of PI-CASC seminar. That'll be on Tuesday, February 4th at noon here in Hawaii, where we'll hear from Leila Kilolu on energy justice, including analyzing community benefits for wind energy projects in the U.S. If you're logging off of Zoom, you will get a seminar that pops up. Please use that opportunity to give us any ideas for future speakers. Some of our speakers this year have come from your suggestions. So thank you all for joining us. We do have pie. Rachel has brought a pie that she'll bring out in a minute. Going along with our Slice of PI-CASC theme. So yeah, it's a thing we do here. Thanks to Rachel. But again, thank you all for joining us, and a big mahalo to you, Aurora, for joining us today.
Thanks.
Sharing.
Thank you.